Myself, I am Dr. Jntuh. In this class, I am going to discuss with the various process scheduling concept, scheduling algorithms. Before moving to the topic, these are all the contents which we are going to discuss now. We are going to discuss about the process scheduler, preemptive and non-preemptive scheduling, CPU schedulers, scheduling algorithms. There are different types of scheduling algorithms are there. Moving to the first topic, process scheduler. As we know that CPU is capable of scheduling most of the multi-programmed systems. And in the scheduling, the switching is a more important concept. The process may be capable of switching from one process to other process with the help of a CPU. Hence, the computer become more productive one. CPU scheduling is an important process which run on a single processor machine where only one process can run at a time. Other process in the CPU has to be rescheduled until the completion of the particular process. The objective of the multiprogramming is to have the same process that is running all the times to maximize the CPU utilization and the resource utilization. As we know that a process is going to be executed until it must wait for the input-output condition to be performed. With this, the multiprogramming concept, each time the productivity of the CPU has been increased. Process scheduler can be done in two different categories. One is CPU execution, another one is input and output wait condition. These are the two process of process scheduling. Process execution consists of the two different cycles. That is, one is a CPU execution and another one is a input output condition. Whether in a CPU execution, a system is going to request start a termination, and after that the request is completed, it will terminate after the particular process has ended. CPU burst is otherwise called when a process is going to begin the execution in the CPU. In the IO burst, it is compared with another process when the CPU is going to be wait for the input output condition of the particular process. That is called as CPU wait condition of input and output process. This can be explained with the help of this particular cycle. Here we are going to load a program, or we can read a file, or we can load a file. It will wait for the particular input output condition of a particular file to be waited in a cycle. So this cycle is called as a CPU burst cycle. Here the value of the particular index may be incremented and the content is being written into the particular file. It will wait for again for the input output condition. Finally, the particular file has been loaded and added in the particular register, and it can be read in a file. This is how a process is going to be wait in the two state, that is CPU cycle state and in the input and output buffer state. The next topic is the CPU scheduler and dispatcher. While in the CPU scheduler, whenever the process is going to be takes place, the CPU sometimes become ideal. The operating system must select any one of the process which is going to be executed in a ready queue, and that process is going to be executed for a while. The selection process is carried out only by the short-term scheduler or a CPU scheduler. The scheduler will schedule the particular process from the particular processes which are available in the memory that is ready to going to be the execution state. Others will be waiting in a queue. This type of scheduler is called as a CPU scheduler. The CPU itself select the particular process to run an application in a file. Then moving to the next topic, dispatcher. It is called as a module that gives the control over the CPU. Here, the process is selected by the short-term scheduler. The concept of switching constant is performed in this type of scheduler. Here, the jumping can also perform by the user program. The dispatcher is capable of performing the process as fast as possible during the process context switch. This time is taken for dispatcher to stop one process and start another process to run in a particular latency period. Moving to the next topic, preemptive scheduling and non-preemptive scheduling. Whenever the CPU is going to schedule a process, it may be run in different condition, that is ready state, running state, waiting state, and termination state. Whenever a process switches from the running state to the waiting state, it is a first condition of a particular process. Whenever a process switches from the running state to the ready state, it maybe occurs and interrupt is going to be occur in this particular process. Whenever a process going from a waiting state to ready state, it will wait for the input and output operation to be completed in a particular process. The fourth condition, a process is going to be terminated. So this is how the fourth situation can take place in the preemptive and the non-preemptive scheduling. So this can be preempted by using the scheduling from the running state to waiting state. It is called as a preemptive scheduling, and from the process creation to the termination state, it is called as a non-preemptive scheduling concept. While in the preemptive scheduling, a process that is going to be switches from a running state to a ready state, it will wait for a ready state, whether the resources available by the CPU are limited amount of time, and at the time we can perform the lowest priority task and it resumes to the higher priority level. Based on this preemptive scheduling, the round robin is the best example for this preemptive scheduling. Non-preemptive scheduling means the CPU has been going to allocate some of a process. The process keeps the CPU until it is going to be terminated by from the switching to a waiting state. This process is called as a non-preemptive scheduling. In this scheduling, once the resources that is allocated by the CPU to the process will hold the CPU until it will get from the termination state. The example for the non-preemptive scheduling are first in, first out algorithm and first come, first serve scheduling algorithm are the popular examples of this non-preemptive scheduling. Coming to the scheduling criteria, CPU utilization is the major criteria that is used in the scheduling process. Whenever the CPU is busy as possible, the CPU utilization can be ranges from a 0 to 100. In this type of system, we can select a light loaded performance or a heavy loaded performance. Throughput is another important criteria of a CPU. If a CPU is busy and it is going to be executing a process, then the work is being done. Here, the work is measured by number of process that has been successfully completed per unit is called as a throughput. Turnaround time. Turnaround time is nothing but an interval from the time of submission of a process, the time of completion is called as a turnaround time. Moving to the next criteria, that is waiting time, the CPU scheduling algorithm does not affect the amount of time by which a process is going to be executed in an input-output condition. It affects only the amount of time that a process spends waiting in a ready queue state. The waiting time is the sum of period that is spent in waiting a ready queue time. Response time is nothing but it is an time. Turnaround time, that may not be a best criteria for this. It can be measured from the submission of a request until the first response is going to be produced. This response is called the response time. Moving to the next topic, that is scheduling algorithm. As we know that CPU is capable of dealing with different types of processes which are existing in a ready queue and in the termination queue. Based on this classification, we are having two different types of scheduling. One is preemptive scheduling and another one is non-preemptive scheduling. Based upon the CPU performance, the scheduling algorithm can be classified into first come, first serve scheduling, shortest job first scheduling algorithm, priority scheduling, round robin scheduling, multi-level queue scheduling, and multi-level feedback queue scheduling. In this class, we are going to discuss with the first in, first out, that is first come, first out scheduling algorithm, which is otherwise called as first come, first served FCFS algorithm. Here, the process that is requested by the CPU will allocate the CPU at first. Whichever they are allocated will be waiting in a first come, first serve basis, which all of the process will be waiting in the process control block will be added to the tail of a process. Whenever the CPU is free, it is going to allocate the process at the head of the queue. The remaining running process are in the queue. So this is a diagram explaining three processes that is going to be run in a process, that is P1, P2, P3. The available burst time of this particular process is for P1, the burst time is 24, and the P2, the burst time is 3, and the P3, the burst time is 3. Okay, moving to this one, we are going to calculate the waiting time for each period. The waiting time of each period can be calculated with the help of a formula. So this can be arrived with the help of this particular sequence. For example, each waiting time and arrival time is going to be calculated with the help of the sequence. So this is the given question here. Here we are going to calculate the turnaround time first. Turnaround time for this, the formula is completion time minus arrival time. What is the completion time given here? 9, 17, 3, 19 and 13. Okay. What is the arrival time here? Here the arrival time is 4, 6, 0, 6 and 5. Okay. Now the formula is completion time minus arrival time. Here we are having, for example, for the processor P1, we are having the completion time of 9 and the arrival time of 4. Hence, we are calculating 9 minus 4, the value is 5. So for the processor P2, the completion time is 17. And here the value is 6. 17 minus 6, the value is 11. Like this, we have to calculate the turnaround time for the particular sequence. What is a waiting period? Waiting period is nothing but we are going to calculate the turnaround time which we have arrived and the burst time initially in the question has been given. For example, here the turnaround time of the processor P1 is 5 and here the burst time is 5. Hence, 5 minus 5, the value is 0. Next, for the processor P2, here the turnaround time is 11 and in here the burst cycle time is 4. 11 minus 4, the value is 7. Like this, we have to calculate the waiting period of a particular time. After that, we have to calculate the average turnaround time and the average waiting time. Average turnaround time is nothing but what are all the processes which we get the turnaround time. We should add all the 5 processor value and it is going to be divided by 5. For example, 5 plus 11 plus 3 plus 13 plus 8, which is divided by 5, we get 8 units. Likewise, waiting time is all the waiting period for a processor from P1 to P5. We have to add this value and divided by number of processes. 0 plus 7 plus 0 plus 11 plus 4 divided by 5, we get 4.4 units. After that, we have to represent this particular FCFS scheduler algorithm with the help of this format, which format is called as a Gantt chart. So this is a format of a Gantt chart. For example, for a processor P1, this is the calculation of time. It will start the process at 0 time. For the P2, the waiting time of a process P2 is 6. For a process P3, the waiting time, it has been arrayed from here. Okay, waiting time has been arrayed from the particular sequence. Here we have to represent that particular value. For the process P3, we have 14 millisecond and process P4, we have 21 millisecond. We have to take the forward value of a particular processes here. Okay. After using that, we have to add all the waiting period of the particular sequences. That is 0 plus 6 plus 14 plus 21. We are getting 10.25 millisecond. Thank you.